Math 1314, section IC1, spring 2022, Tyler Junior College, section 3.4, solving quadratic equations, factoring, video 1, how to solve quadratic equations by factoring, part 1. At some point, I'm going to have to let the cat out of the bag as to what makes an equation quadratic. You'll see that in the very next slide. But I want to point out that we're going to be solving equations. And anytime you are solving an equation, your goal is always the same. Figure out what the variable equals, visually isolate the x or whatever the variable is. So keep that in mind as we move forward, that our ultimate goal is to isolate the x and figure out what it equals. Let's start by taking a look at a couple of equations, one of which is linear, one of which is quadratic. And if you've forgotten what makes an equation linear, I'll remind you here in a moment, and also introduce what makes an equation quadratic. Equation A is solve x minus 7x plus 12 is equal to 0. Equation B is solve x squared minus 7x plus 12 is equal to 0. I think it's fairly evident, but what's the main difference between the two equations? The answer? The second equation has a power. That power is on the x, and specifically it's a power of 2. Now, if we wanted to be a little bit more descriptive, let's bring back the term linear and what it actually means. In algebra, linear means highest power is 1. Actually, I'm going to bring in a new term here. The term is degree. When you have a polynomial, a sum or difference of powers of a letter or multiple letters, the highest power is called the degree. So I'm going to bring that new word into play now because it's the word we're going to be using later. But the degree is 1, meaning the highest power on any variable is 1. By contrast, the second equation is quadratic. And what quadratic means is that the highest power, or the degree, is 2. So quadratic is an adjective describing the highest power in a polynomial, in this case, a power of 2. There are other adjectives for higher powers. When the degree is 3, it's called a cubic. When the degree is 4, it's called quartic. And when the degree is 5, it's called quintic, but we rarely ever use those words, except maybe cubic. Well, let's get back to the main difference between solving these two equations. Clearly, one is linear and one is quadratic, but does that matter? And the answer is absolutely. Why? Well, as of right now, we do have a technique for solving the first equation. It's linear. And we've solved linear equations before. Full disclosure, I'm not using the best stylus that I have. I left it at home and I'm at TJC right now. So I'm going to make sure that the drawings are as best that they can be, but you've been warned. If we were solving something like x minus 7x plus 12 is equal to 0, we have a protocol for doing this. One of the moves is if there's multiple x's, do something about it. These x's are on the same side. We can just combine them and get negative 6x. And then we get a basic linear equation, negative 6x plus 12 is equal to 0. We can solve that by subtracting 12 from both sides. That would cancel the 12 on the left and leave a negative 12 on the right. And then we could divide both sides by negative 6. Negative 12 divided by negative 6 is positive 2. I am skipping the actual steps. I'm skipping writing of the actual steps. I didn't write minus 12 on both sides. Didn't write divide by negative 6 on both sides because those are moves that we should be able to pull off pretty easily without me writing them every single time. But yeah, so solving that linear equation is straightforward. We've done it before. But what about solving the quadratic equation? What about solving x squared minus 7x plus 12? Well, that's a tougher one to solve. We can't solve it the way that we solve the linear equation. And why not? Well, one of the problems in the linear equation is that it started out with two x terms, an x and a minus 7x. But those were like terms. And as a consequence, they could be combined into a single term, meaning at this juncture in the problem, which I'm about to highlight, we were down to one x and all we had to do was proceed to get it by itself. So we overcame the obstacle of multiple x's in the equation by combining them because they were like terms. But in the quadratic, we don't have that luxury. In the quadratic equation, we do have two x terms, but one's an x squared and one's a minus 7x. These are not like terms, meaning that even though they have the same letters, they don't have the same powers. when they're not like terms, excuse me, you cannot combine them into a single term. The rule for combining like terms is simple. If the letters match and their powers match, then just add the numbers in front of them and leave everything else alone. Just like when we put together x minus 7x, the letters matched x, their powers matched, implied powers of 1. So we simply combined the numbers in front, and the numbers in front were 1 and -7, which gave us the -6. We don't have that luxury down here. So what do? Because that presents a problem. Our goal is still the same. Our goal is to get the x by itself. But as long as we have two x terms that are not like terms, we can't combine them. Therefore, we can't overcome the obstacle of having too many x's in the equation en route to getting the x by itself. So now the question is, what do? Well, before I show you what we're going to do, I want to take you back to elementary school for a moment and point out that multiplication has a really convenient property. It's not illustrated in the example you see here, but in the next one that will be on the right side of the screen. Let me show you what I mean. Let's say that you're in elementary school doing algebra, which you've done because anytime you have an unknown value, that's an algebra problem. But in elementary school, they usually use shapes instead of letters, and they don't call it algebra because if they did, it would scare the teacher. Really, some teachers would be okay with it. But let's say I asked you, and let's make this a different shape. I don't want these to be the exact same shape. Let's say we have square, and we'll just put an empty circle here. It's going to look like a 0, but it's really just a circle. Put it where I want it. Let's say we have square times circle equals 6. And I ask you, give me two numbers I can put in there that will make it true. What times what is equal to 6? Well, 2 times 3 is equal to 6. Let's write it below. 2 and 3 would work. But now what if I said, all right, give me a pair, but don't use 2 or 3. Oh, 1 and 6. Okay, good. Well, give me a pair, but don't use 1 and 6. Then you start going, oh, there are no more numbers until you expand your number base, your number system. Because if you say there are no more numbers, you're only thinking on the right side of 0 on a number line. And the minute I say that, people are like, oh, we can use negatives. -2 times -3. And I said, great. Now give me a different pair without using any of these 6 numbers, -1 and -6. But I'm going to ask it again. Can you give me a different pair without using any of those 8 numbers? And this is where some people lock up until they realize there's lots of numbers they're not considering, the numbers that are between integers, aka fractions and decimals. So now if we open up fractions, I can say something like 12 times 1/2, which is 6. And then I say, okay, but can you give me another pair without using those? And you'll notice every time you give me a pair, I cross it out and say, can you give me another? 18 times 1/3, 24 times 1/4, all of these equal to 6. But here's the thing about multiplying to get 6. I don't care what two numbers you give me. I can throw them out and say, give me a different pair, and there will always be another pair. So what that means is, well, there will always be another pair if you let in negatives and fractions. So what that means is when you multiply two things to get 6, there is no guarantee what either of the numbers has to be, because every time you give me a pair of numbers, I can throw them away and say, yeah, go find another pair. So there are no guarantees when you multiply to get 6. And in fact, when you're multiplying, there are no guarantees that you'll get anything. I'm going to rephrase that again. When you're multiplying to get a certain product, in this case 6, there are no guarantees what two numbers you multiplied to get there, because I can always come up with a different pair. Every number has that flaw when it comes to multiplication, except for one number. And guess what that number is? That number is 0. And if you give me a second, I do want to replace, well, we'll just leave it there. Just keep in mind that they are two different squares. How about I make the square a different color so that we can say, yeah, it actually is a different looking square. We'll make it a green square. All right, so now let's play the game. And I say, okay, give me a pair of numbers that when I multiply, get 0. And there's a lot of answers you can give me. For example, maybe you'll say 7 times 0. Why 7? I don't know. And then I say, that's good. Let me throw those out. Now give me a different pair. Give me a pair that doesn't use 7 or doesn't use 0. Good luck with that. Most common reply I'll get something is like -5 times 5. But the problem is that doesn't multiply to give 0. That multiplies to give -25. They add to give 0. but they don't multiply to give 0. So give me a pair of numbers that multiplies to give 0, but don't use 7 and don't use 0. We've already used those. Can't do it, can you? If you give me any two numbers that aren't 0, their product is not going to be 0. So as long as I write two numbers here and neither is 0, then they don't work. The only way you can multiply and get 0 is if one or more of your numbers is 0. Everybody knows that 0 times anything is 0. What a lot of people don't pause and realize is that's the only way you can multiply and get 0 is if one or both of the numbers you start with is 0. And that's the convenient property that 0 has. You can't multiply and get it unless you start with it. Now, how's that going to help us? Well, you'll see here in a second. So this leads to something called the zero product principle. Now, I've seen this called multiple things because two of the words can be interchanged with other words. I've seen it called the zero product principle. I've seen it called the zero product property, and I've seen the word product replaced with factor, the zero factor principle or the zero factor property, but they all involve the word 0. So what does it say? Well, it says what we basically just said a minute ago. If the product of two or more factors equals 0, then at least one of the factors must also equal 0. We could also write this symbolically. It would go something like this. Let's put this in red. If AB equals 0, meaning a multiplication problem equal to 0, then A equals 0 or B equals 0. It could be both, because 0 times 0 is 0, but you're guaranteed that if you multiply and get 0, at least one of the things you multiplied with, one of your factors, has to also be 0. Now, why is that useful? Well, take a look a little bit closer at this last thing from a structure perspective. In this first equation on the left side, you have A and B glued together, but in the conclusion of the statement, they're separate from each other in their own individual equations. So what the zero product principle allows us to do is to take things that are multiplied inside of one equation and separate them into their own equations under the right conditions. The conditions are, on the left side, you have to be a multiplication problem. And on the right side, you have to be equal to 0. So if you are a multiplication problem equal to 0, then I can split you into smaller equations by putting each part of the multiplication by itself equal to 0. Well, how's that going to help us? Well, let's go back to this quadratic equation. Solve x squared minus 7x plus 12. Remember, our obstacle is we've got too many x terms in the equation that are not like terms. We've got the x squared and we've got the minus 7x. Not like terms because even though they have the same letters, those letters don't have the same powers. We can't combine them into a single term because they're not like terms. So we can't get to our goal of the x being by itself. I've got too many x's in each other's way. If this were a multiplication problem, it's not, and it's an addition subtraction problem. But if this were a multiplication problem equal to 0, something times something equals 0, then we could write each half equal to 0 separately. So now it boils down to the question, is there a way to take this addition subtraction problem and rewrite it as a multiplication problem? Well, if you watch the factoring review videos, and if you don't know what I'm talking about, I'll show you real quick. But if you watch the factoring review videos, there was an announcement about it. You'll see some announcements that I haven't posted yet because this is the teacher side of things. But you'll see, where is it? I think it's on what you should be working on tomorrow. So this is the video for tomorrow, and it might be in today's announcement. If you haven't completed these, work on them. You should work on the following today. To get a head start tomorrow, you should work on the following. Watch the factoring review videos in the weekly work module. If you go to the weekly work module, where the weekly work for the 0314 support class lives, prior to the 4th weekly work, there are 5 factoring review videos. If factoring is not in your wheelhouse, I strongly recommend watching them because factoring is a skill that will come up again and again in this class starting today. And it's a skill that a lot of people lack going into a college algebra class, not just a co-requisite pair, just college algebra in general. I've seen calculus students that struggle with factoring, but I would strongly recommend watching these factoring videos. And without rehashing what they all say, Factoring is a process where you rewrite something as a multiplication problem. Let me say that again. Factoring is a process where you rewrite something as a multiplication problem. I want this addition subtraction problem, x squared minus 7x plus 12, to be rewritten as a multiplication problem. So we are actually asking, can we factor this? So I'm going to say factor the polynomial. It's quadratic, its highest power is 2. Now, if you know how to factor, great. If you don't, go watch the factoring review videos because it's going to be crucial for this section. But if you were to factor x squared minus 7x plus 12, you would get in no particular order x minus 3 times x minus 4. You could check this by foiling this out, first, outside, inside, last. The outside term would give negative 4x. The inside term would give negative 3x. Those would combine to make the negative 7x in the middle. And then the last product, negative 3 times negative 4, would give positive 12. The first part of the product here would just give the x squared. But again, without getting into all the details about the factoring, because you can watch the review videos, this polynomial, this quadratic trinomial, tri meaning 3 terms, x squared minus 7x plus 12, this quadratic trinomial factors into x minus 3 times x minus 4. And why is that useful? I now have a multiplication problem on the left equal to 0 on the right. And the zero product principle says, if you have a multiplication problem equal to 0, then either the first part is equal to 0 or the second part is equal to 0. So I'm ready to make this split. Factor the polynomial. You got a multiplication problem equal to 0, which means either the first factor is equal to 0, x minus 3 is equal to 0, or the second factor is equal to 0, x minus 4 is equal to 0. And at this juncture, the problem that was preventing us from our goal has been overcome. The problem is we had too many x's that were stuck together in the same problem, and now they're separated. These are easy to solve. If you solve x minus 3 equals 0, you get x equals 3. If you solve x minus 4 equals 0, you get x equals 4. So this is the key move, the key process for this video. And by the way, the technique that we just did, which I'm about to summarize, is going to be a recurring issue throughout the rest of the course, solving an equation by factoring. So how to solve a quadratic equation by factoring? 4 steps. Step number 1. If necessary, rewrite the equation until it reads quadratic polynomial equals 0. Remember, quadratic means highest power is x squared, and we want everything on the left and equal to 0 on the right. Some equations will start that way. This example did. At the top, x squared minus 7x plus 12, that's a quadratic polynomial, and it's equal to 0. So this one was already done. In the next video, we'll look at some examples where it's not ready yet, and we have to do this first step. Didn't mean to show you all that. No harm, no foul. Step 2, factor the polynomial completely, meaning to rewrite it as a multiplication problem. The word completely is because later there will be problems that involve more than one step when factoring. Step 3, set each factor equal to 0. That's where we split this equation and wrote x minus 3 equals 0 and x minus 4 is equal to 0. That overcomes the obstacle of too many x's being in each other's way. And then lastly, solve each smaller equation. So if you wanted to boil this down into 4 words, because I like capturing the essence of this flow minimally as possible, I can summarize it in 4 words. 0, meaning get the equation equal to 0. Factor, meaning rewrite the polynomial as a multiplication problem. Split, meaning split it so that each factor is equal to 0, and then solve. This 4-step flow, get it equal to 0, get it factored, split it and solve it, is going to be recurring throughout the rest of the semester. So this will not disappear after this section. All right, so that's it for this video. In the next video, we're just going to work several examples, but the sooner you get this 4-step flow down, the better. And I'll be honest, the step that is going to throw you off, as it has always done since I've been teaching this class, is the second step, because it requires you to be able to factor.